Let us now have a look at question 2. Question 2.1. In the diagram alongside, O is the center of the circle, ABDC. O is the center of circle ABDC, meaning the vertices A, B, D, and C, they are on the circumference of the circle. Then we are further told that O is joined to B and is also joined to C. And we are given the size of angle OBC, and it is equals to X. Angle OBC is equals to X. Alright, so like we did with question 1, now you can pause the video if you have not yet done the analysis. Pause the video and do the analysis based on the statements that were given in with regard to the diagram, and also analyze the diagram and identify as many theorem statements as you can, and probably what determine the sizes of all the other angles that you can in terms of what, in terms of X. Alright, then once you are done with your analysis, you can then unpause the video. Alright, now question 2.1.1. Question 2.1.1, determine with reasons the following angles in terms of X. 2.1.1, it is angle O1. Alright, here is angle O1. We know the size of angle OBC is equals to what? X. But let's look at what? OB and OC. We can see that OB is equals to OC, radii. Therefore, this means what? In triangle OBC, triangle OBC is what? Is an isosceles triangle. Therefore, we know that also angle C1 will also be equals to X, because angle C1 is equals to angle OBC, and the reason for that is that these are angles that are opposite equal sides of a triangle. Therefore, it will be easy for us to find the size of angle O1 using sum of angles in a triangle. So now that we have seen how we can calculate the size of angle O1, we can actually what? Do so. Firstly, we are seeing what? Angle OB is equals to angle OC, and these are what? Radii. Right? We say side, not angle, but rather side OB is equals to OC. Line segment OB is equals to line segment OC. The reason, radii. Then we can say angle C1 will be equals to what? Angle OBC. Here is angle OBC. And the reason for that, these are angles opposite equal sides. Angles opposite equal sides. Therefore, angle C1 will be equals to X. So now we know that C1 will also be equals to what? X. Then we can say angle O1 plus angle OBC plus angle C1 will be equals to 180 degrees. That is what? When we are in triangle OBC. Then the reason for this statement, these are sum of angles in triangle. Then we can substitute OBC and C1 and solve for angle O1. Then we say angle O1 plus angle OBC is X plus angle C1 is X. This will be equals to 180 degrees. Therefore, solving for O1, we get O1 is equals to 180 degrees minus 2x. 180 degrees minus 2x. Right. Now we know the size of what? O1. O1 is 180 degrees minus 2x. Okay, now on question 2.1.2, we must now determine the size of what? Angle A in terms of x. Remember, now we have calculated C1 is x, angle O1 is 180 degrees minus 2x. Now we must find angle what? Angle A. Then we say angle O1 is twice angle A, and the reason for this is that angle at center is equals to 2 times angle at circumference. Then, but what is the size of angle O1? 180 degrees minus 2x is equals to 2 times angle A. And then from there, dividing both sides by 2, 90 degrees minus x is equals to A. Therefore, angle A will be equals to 90 degrees minus x. So here is angle A, 90 degrees minus x. And then 2.1.3, determine the size of D in terms of x. Then we can see that quadrilateral ABDC is a what? Is a cyclic quadrilateral, because the vertices A, B, D, and C, they are on the circumference of the circle. Therefore, we can say angle A plus angle D will be equals to 180 degrees. And the reason for that, opposite angles of a cyclic quad, opposite angles of a cyclic quad. Then we say, what is the size of angle A? Is 90 degrees minus x plus angle D is equals to 180 degrees. Then solve for angle D. Angle D will be equals to 90 degrees plus x. That will be the size of angle D. Okay, we are done with 2.1. Let us now go to question 2.2. Question 2.2. In the diagram, alongside PR is a chord. PR is a chord of the circle with center M and radius R. So M is the center of our circle. The perpendicular from center M intersects PR at N. Therefore, this means what? This means MN is perpendicular to PR, and they have shown here that with the size of what? Of 90 degrees. Now that MNP is equals to 90 degrees. Therefore, we know that MN is perpendicular to PR. Okay, the perpendicular from center M intersects PR at N and the circle at Q. Therefore, this simply means what? MNQ is a straight line. We are further given the sizes of line segment PR is equals to 120 degrees. QN is equals to not 120 degrees, but rather 120 units. Yeah, this is the length. The length of PR is 120 units. The length of QN is 20 units, and the length of MN is X units. Now, question 2.2.1. Write R in terms of X. Write R in terms of X. Now where is r? R is our what? Is our radius. Ne? Our radius pm. Now firstly, mn we are given mn is x. Mn is x. We are also given what? Qn, which is 20 units, and we are also given what? PR. Here is our PR, which is equals to what? 120 units. 2.2.1, write R in terms of x. R is what? Is the radius. The radius PM. But let us look at also what? MQ. You see MQ. MQ is also a what? A radius. Remember, a radius is a line that is drawn from the center of a circle to the circumference. So both MP and MQ are lines that are drawn from the center of the circle to the circumference of the circle. Therefore, those two lines will be what? Will be equal. Then we can say R will be equals to what? MQ. And the reason for that is radii. R is a radius, MQ is also a radius. Therefore, R will be equals to what? What is MQ? MQ will be MN plus NQ, which will be what? X plus 20. Therefore, R will be equals to X plus 20. That will be what? R in terms of X. R will be equals to X plus 20. Okay. Then 2.2. Remember now we know we are given here that Mn is X and Q is 20 and PR is given by what? 120, and we have just calculated R. R is equals to what? R is equals to X plus 20. Now 2.2.2, calculate the value of R. Now what is R? R is X plus 20. So if we are to calculate the value of R, therefore it means what? We need to first find the value of X. If we can find the value of X, then we can say that value plus 20 will give us what? The value of R. Now, let us have a look at what now? Triangle MNQ. Triangle MNQ. Not MNQ, but MNP. Triangle MNP, which is a what? A right angled triangle, where we know MN is X, where we know MP, which is what? R is what? Is X plus 20. But what we need to find is what? Is PN. If we can find PN, then we can use what? The theorem of Pythagoras to solve for X. So how do we find PN? Going back to the diagram and also from the statement, we know that MN is perpendicular to what? To PR. Therefore, and M is the what? Is the center. Therefore, we should be thinking about what? Our theorem statement that says a line drawn from the center of a circle perpendicular to the chord bisects the chord. Therefore, what does it mean? It means PN is equals to what? NR. Therefore, if we know the length of PR, it will be easy for us to calculate the length of what? Of PN. Therefore, we can say PN will be equals to what? 120 divided by 2. And the reason for that is what? That theorem statement, line from a center perpendicular to the chord bisects the chord. Then the reason will be line from center perpendicular to chord. Line from center perpendicular to chord. Then from there, PN will be equals to what? 60 units. Then Now that we have Pn, then we can what? Use Pythagoras in triangle MNP to calculate the value of x, and then from there we'll be able to find the value of what? Of r. Then we can say Pm squared is equals to P or NP squared plus Mn squared. What is Pm squared? Pm squared is r. Not Pm squared, but rather what? Pm. Pm is r, but what is the value of r? I mean, what is r in terms of x? R is x plus 20. X plus 20, but this is what Pm squared, therefore it will be x plus 20 all squared is equals to NP, we have just calculated it, is what? 60 units. Therefore 60 squared plus Mn is x, and then we square it. And then from there, x plus 20 squared, x squared plus 40x plus 400 is equals to 60 squared, 3600 plus x squared, and then from here let's solve for x. Transposing the equation, we'll be left with 40x will be equals to 3200. Remember, x squared minus x squared will be 0. 3600 minus 400 will be 3200, and then from there divide both sides by 40. We get x is equals to 8. We get x is equals to 8. Now that we know that x is equals to 80, then we say r is equals to what? Remember, r is equals to x plus 20, but what is the value of x? The value of x is 80. Then we say plus 20, therefore r will be what? R will be 100 units. That will be the value of r, 100 units. Okay, and then now let us have a look at question 2.3. Question 2.3. In the diagram alongside circle QRS has tangents PQ and PS. Tangents PQ and PS. Already you must be thinking about what? The theorem statement that say tangents drawn from the same point outside the circle will be equal in what? In length. Ne? Alright. Then PT is parallel to SR. PT is parallel to SR. There are parallel lines, so you should be thinking about your what? Corresponding angles, alternating angles, co-interior angles. PT is parallel to SR with T on QR. T is on chord QR. Therefore, this tells us that QTR is a straight line, or QR is a straight line. Angle S1 is equals to X. We are given the size of angle S1 here, which is equals to what? X. Okay, now let's get to the questions. 2.3.1. Remember, pause the video, do the analysis of the statement given together with the diagram, identify as many theorem statements as you can, and also probably find the what? The sizes of other angles in terms of what? In terms of X. When you are done, you can then now what? Go back to the video as we continue with question 2.3.1, which says name with reasons 3 other angles equal to X. 3 other angles equal to X. Okay, the first angle which is equals to X is what? Angle S1. But remember, we were told that PQ and PS are what? Are tangents. Therefore, we can say what? PQ is equals to PS. These are tangents that are drawn from the what? From the same point outside the circle. And the reason that we are using this theorem statement is because once we can identify that PQ is equals to PS, it means what? Triangle PQS becomes a what? An isosceles triangle. Therefore, angle S1 will be equals to angle Q1. Therefore, Q1 will be equals to X. So we can first say PQ is equals to PS. Reason for that, these are turns from same point. Turns from same PT. Turns from same point. Tangents drawn from the same point outside the circle will be equal in length. Then we can then say Q1 will be equals to what? Will be equals to S1, which is equals to X. The reason for that, remember we said now triangle PQS becomes a what? An isosceles triangle. Therefore, these are angles opposite equal sides. These are angle opposite equal sides. So that is the first angle. X. Angle Q1 is now what? X. But then PQ, PS are what? Are tangents. So let's go to tangent PQ. You see, tangent PQ, angle Q1 is an angle between tangent PQ and chord QS and chord QS. Then we know from the tangent theorem that an angle between a tangent and a chord will be equals to an angle in an alternate segment subtended by that chord. Therefore, we know that now what? Angle Q1 will also be equals to angle what? Will also be equals to angle R, which will be what? X. And the reason for that is what? Tan chord theorem. Then we say angle R, not R1 but just R, angle R will be equals to angle Q1. Reason? Tan chord theorem. Therefore, we know that angle R1 will be equals to X. So now we have found what? Two angles equals to X. And then lastly, remember, we know that PT is parallel to SR. Therefore, you need to be thinking of your what? Corresponding angles, alternating angles, and co-interior angles. So PT, since PT is parallel to SR, it means what? Angle R will be equals to angle what? T1. R will be equals to T1. Therefore, T1 will be equals to what? X. And these are what? Corresponding angles. Then we can say angle T1 will be equals to angle R. The reason for that, corresponding angles. And then from there, you need to what? Give the what? The two parallel lines. The parallel lines. We're saying PT is parallel to what? To SR. Angle T1 is equals to angle R. Why? Corresponding angles, because PT is parallel to SR. Therefore, T1 will be equals to what? X, since angle R is equals to X and angle R is equals to angle T1. So now we have what? We have named three angles of which they will also be equals to X, and then that is angle Q1, angle R, not R1, angle R. We only have one angle R, and also angle T1. Those are the three angles that we have identified here that will be equals to what? X. Okay, now question 2.3.2. 2.3.2. Let's just write down the sizes of the angles that we have now calculated. Q1x, T1x, S1 we were given is x. We also calculated that angle R will also be equals to what? X. All right. Now, 2.3.2, prove that PQST is a cyclic quadrilateral. PQTS is a cyclic quadrilateral. All right. Now, let us have a look at what quadrilateral PQTS. Look at line PQ. Line PQ subtends angle S1. Line PQ subtends angle S1, but also line PQ subtends angle T1. You see, it subtends angle T1, and angle S1 is equals to x, angle T1 is equals to x, therefore angle S1 is equals to angle T1. Therefore, this means what? You need to be thinking of your angles in the same segment. But remember, we don't have a circle here. Therefore, we cannot be talking about what? The segment. But remember, this will happen when what? When we are having a circle. Therefore, we can now conclude to say what? PQTS is a cyclic quadrilateral. Reason being what? Reason being the line which is PQ, and PQ subtends what? Subtends equal angles. Line PQ subtends equal angles. Therefore, it means what? If we are to draw what? A circle that passes through P, Q, T, and S, we will be having a what? A cyclic quadrilateral. Hence, we'll also be having what? Angles in the same segment. So for this one, now that we know that T1 is equals to angle S1, and both T1 and S1 are subtended by the what? By the same line segment. Therefore, PQTS will now be a what? A cyclic quadrilateral. So, now we can say T1 is X. T1 is X. Okay. Prove that PQTS is a cyclic quadrilateral. We say angle S1 will be equals to angle T1, and this is because both angles equals what? Equal X. Therefore, we can say PQTS is a cyclic quadrilateral, and the reason is that line segment subtends equal angles. Line subtends equal angles. Alright, 2.3.2, prove that angle S3 will be equals to angle Q1. Here is our angle S3. Prove that S3 is equals to Q1. Q1 is X. Prove that S3 will also be equals to what? X. S3 will be equals to Q1. Alright. Then we say angle Q1. Angle Q1, remember, now that we have proved that PQTS is a cyclic quadrilateral. In question 2.3.2b, we use the fact that PQTS is a cyclic what? Quadrilateral. Then we can say angle Q1 is equals to what? Angle T2. Angles in the same segment. And angle T2 is equals to angle S3. Alternating angles. You see, T2 is equals to S3. Alternating angles because PT is parallel to S3. Therefore, then we can conclude to say angle S3 will be equals to angle Q1. So so we can start first by saying angle T2 is equals to angle Q1. Reason? Angles in same segment. Angles in same segment. The two angles are subtended by what? The two angles are subtended by chord PS, or we can now say what? Arc PS, since PQTS is now a cyclic quadrilateral. But now we know that angle T2 is also equals to angle S3. The reason for that, these are alternating angles because PT is parallel to SR. Therefore, we can now conclude to say, since T2 is equals to Q1 and T2 is equals to SR, this makes angle SR equals to angle Q1. Alright, we are now done with question 2.3.